Okay, so I think we have sufficient number to start with. Okay, so we'll start then. So if you have any doubt, any question, you can ask from the last class. Okay, so otherwise we'll proceed. I hope all of you have understood the things, right? Vishal, up to the last class, any doubt? I hope no. Okay, so in the last class, basically, we have completed the main part from this particular module, which is about the type of friction drive. And that was, we have mostly discussed the bell drive in details. Okay, also we have seen how also the rope also works, just like the kind of in a trade and all. Okay, so in the groove and all. Okay, how it is generally used. Okay, and similarly, we have studied about all the flat bell, P bell, etc. We know the different ways of construction, not construction, the designing of this particular bell corresponding to different, suppose whatever is the size of the pulleys that will be required, maybe the dimensions of the whatever is the bell that we have for a particular work. Okay, so that kind of designing of belt also we have done. Okay, so okay. In the meantime, I think someone has unmuted your. All of you, please be on mute. Okay, some noise is coming from someone. Please mute yourself. If, okay, so I hope I am audible to everyone, right?
Yes, sir.
Okay. So, in the last class, as we have already completed that particular part, the main part from the this particular module. So today we'll be going to the rest of the things. Okay. So that is basically this particular module also talks about the friction in bearing, also some lubrication. Okay. And similarly, some initial thing about friction clutches and bearing and some brake working, friction brake working, that kind of thing only in initial manner. So the rest of the things, that is the drive of the type of friction drive, that is the bell drive, we have discussed in detail. So these things about the type of friction, what is friction, I believe all of you already know. And in the very first for this particular module also we have discussed this thing. But still, I'll be just repeating this thing. I think about friction, its type, etc. Okay. So all those things also in your physics as well as in your engineering mechanics, all of you have studied, right?
Sir, your voice is low, sir.
Am I properly now?
Yes, sir.
Okay. So, I think about friction already you have studied in your engineering mechanics as well as in your physics. Okay. So, but still, we'll just go through it so as to brush up your concepts. Okay. So, now all of you already know when basically two bodies slides one over another. Okay. Or two surfaces. And there is a kind of resisting force that is developed, and that is nothing but the force of friction. Okay. And actually, the force it arises from the fact that whenever the surfaces, okay, even though we are saying that it is very mid like smooth or like that, but in the microscopic level, if you see, actually they have got different undulation, ridges, etc., up and down, that is kind of depression and all, and they interlock between itself. Okay, when the two surfaces try to, you can say, have movement between them, and there's the relative movement is resisted. Okay, and we know that the force of friction on a particular body is parallel to the sliding surfaces, and it also acts in a direction which is opposite to the direction of the movement of this particular body or the tendency of movement of this particular body. Okay, so those things we already know. And in the one of the classes already we have also discussed why it is known as necessary evil, why it is required and all. Now, in our context, why actually we are still once again just going through this thing? Actually, this friction actually it will arise in any two contacting surfaces and all. Okay, and whenever we are saying about this flat belt or V belt, also that's belt rep also we have discussed. There also we have seen that it's a kind of friction, right? And apart from that, the rest of the parts, that is some of the we'll be talking about some bearing, some like clutch friction, clutches, brake, etc. There also you will basically see that as we'll be having contacting surfaces, relative motion, etc. So the it will be related to this particular friction. Okay, that's why we're studying once again. So now, if you recall, I believe all of you already recall. So there are actually different types of friction we can categorize. Like we can have static friction, and it is nothing but the kind of friction that is experienced by two bodies which are in contact, but they are at rest. Okay, at rest, whatever is the friction that is there. Okay, that is nothing but the static friction. So we also have dynamic or kinetic friction. So it's nothing but the friction experienced by two bodies in contact while in motion, and its value is always smaller than less than that of your static friction. Static friction is more than dynamic friction. Okay, and now under that itself, if we consider, then depending on what type of motion we'll have, so sliding friction, rolling friction, those kind of friction we can have. And the sliding friction is nothing but it is due to the sliding of two bodies with respect to one over another, and rolling friction is with respect to the rolling of two bodies, okay, on each other, okay, one over another. And apart from that, this will be important. This term you might or you might not have used previously. Okay, the pivot friction. Okay, so it's what is this pivot friction, or how we can say about discuss about pivot friction. So it's a friction experienced by two bodies due to the rotation of one body around the other. Okay, and these kind of frictions are evident in the case of like footstep bearing and all. And that's why I believe you have seen like how the bearing portion, okay, bearing concept is coming into picture. So generally, pivot, etc., those pivot colors, those things are colors, those things are there in bearing. Okay, and bearing, I believe all of you already know these bearings are highly used mechanical element. Okay, for supporting the shafts and all. Okay, and so in that particular case, so there we can say about this pivot friction. Okay, similarly, we have like we can have solid friction or dry friction. Okay, and this is nothing but kind of friction, okay, which is there in between dry and unlubricated surfaces which are in contact. Okay, then we can consider this as a kind of solid friction or dry friction. Okay, and we can there is another term like boundary friction or sometimes skin friction. Okay, mostly skin friction or greasy friction it is called. Okay, and when actually we'll be discussing about this boundary friction or skin friction, actually now previously in solid friction or dry friction it is unlubricated, dry and unlubricated surface we are talking about, right? Now, the skin friction and all, okay, or boundary friction, actually it is the friction which is experienced by two bodies, which is separated by a very thin layer of lubricant. We already know that actually whenever we're talking about these different mechanical elements which are in contact, which surfaces are in contact and they have got related motion, we know that force of friction is there, and we know the different harmful effect about with respect to the friction, okay, high friction and all. Because of that wear and tear, rubbing of the two surfaces, because of which the wear and tear, pitting, etc., those kind of phenomenon may occur. And we know that to reduce those harmful effect of friction, okay, which is there in between the two surfaces which are in contact, we provide some lubrication. Okay, and whenever we have a very small layer of lubricant, okay, that means the two bodies are separated by a very thin layer of lubricant, then the friction which is there in the bodies, okay, that is nothing but the boundary friction or skin friction. Similarly, we can have this boundary friction is also known as skin friction or greasy friction. Okay, so that means it has got when the two surfaces in contact, it has got a very minute thin layer of lubricant between them. So then it is nothing but the uh, this one is greasy friction. Okay, and in this particular greasy friction or skin friction, what basically happens? we know that surfaces are actually, even though we are saying that it's a smooth surface and all, okay, so it can still have some undulation, some depression, some bulging out, or like that kind of spots, okay. So there may be in the some higher spots, lower spots, that kind of thing. So higher spots on the surface, it actually tries to break through the lubricant film and it comes in contact with the other surfaces, okay, because we are talking about a very small surface, small layer of lubricant only. So whenever we have got a kind of higher spot on that particular surface, it can break through that particular very thin layer of lubricant. Okay. So next, similarly, we can also have there is a term known as fluid friction or film friction, FILM. Okay, it's not the movie or that kind of thing. Okay, so uh, this fluid friction is it is a kind of higher version of this particular lubrication. Okay, so basically this is the nothing but the friction experienced by two bodies which are in contact, but they are separated by a thick film of a lubricant. So in that particular case, that will be known as the fluid friction or film friction. So how this boundary friction or skin friction and fluid friction are different? Actually, in case of greasy friction or skin friction, it is very a minute layer of lubricant. Okay, it is separated by a minute layer of lubricant. And in case of fluid friction or film friction, it's a thick film of lubricant that is there. Okay, and that is how they are different. Understood? Let me know. Hello.
Yes, sir.
Okay, thank you. So, if you recall your EM knowledge, engineering mechanics knowledge, I believe there also you have studied about the laws of friction. Still, we'll just brush it up. So, experimentally, what we have seen that, so the basically this law of friction we can with respect to static friction as well as with respect to kinetic friction we can discuss, or maybe with respect to fluid friction also. So these are somewhat similar only. Okay, and these are kind of experimental evidence that has shown it. Okay, so like we already know that if we discuss with respect to static friction, the frictional force it always acts in a direction opposite to the motion or the tendency of motion. That we already know. That means if two suppose this is the block, okay, and suppose this is the surface, another surface, okay, so these two surfaces are in contact, okay, this one from here and this surface from this particular surface, okay, they are in contact. And if this has got this, suppose this way, if you apply force, and because of that application of force, suppose some movement will be there, so in the opposite direction to the uh, tendency or impending motion, okay, if this way if we have the motion, then force of friction will be in this particular direction. Okay, so that is the thing. And the limiting force of friction is directly proportional to the normal direction. So we already know that due to this particular friction, okay, so there will be a normal direction developed, okay, or n or r. Okay, so it's a limiting friction is directly proportional to the normal friction. Okay, and this force of friction actually it is independent of the area of contact between the two surfaces. Okay, so basically it's actually dependent on the nature of the two surfaces which are in contact. Okay, and actually it depends upon the roughness of the surfaces of both the contacting material. Okay, so the roughness or smoothness ultimately both are related, and it plays a vital role, a direct role in the indication of the friction. Similarly, if we talk about with respect to kinetic friction, okay, so the force of friction always acts in a direction opposite to that in which it is moving. Okay, now it becomes moving body. Previously, it is the impending motion body. Okay, that means motion was not exactly there, but tendency of motion or this way motion has been impended. Okay, in the case of static friction. So similarly, the magnitude of kinetic friction it bears a constant ratio to the normal direction between the two surfaces. And I believe all of you already know F equal to mu r. Okay, so that thing or that expression, the which is with respect to friction, I believe all of you already know. Similarly, the force of friction is independent of the relative velocity between the two surfaces which are in contact, and but it decreases slightly with increase in the velocity. Okay, and the force of friction increases with reversal of motion. And with respect to temperature variation, the coefficient of friction it changes slightly due to temperature changes. Okay. Next, if we discuss with respect to fluid friction, so in case of fluid friction or thick film friction, the force of friction is almost independent of the load. Okay, the force of friction it reduces with the increase of temperature of the lubricant because whenever we are talking about the fluid friction, actually we are talking with discussing with respect to a thick film of lubricant which is separating both the contacting surfaces. Okay, and similarly the force of friction it depends upon the type and viscosity of the lubricant. Okay, you might have seen those who are having suppose bike etc. Okay, so a specific lubricant only we use. Okay, of certain it has got certain property like the viscosity of this particular lubricant and all. Okay, so definitely depending on the what's the viscosity level of this particular lubricant, fluid friction, okay, level of force of friction, that is the fluid friction will talk is there. Okay, that will depend. And once again here also the force of friction is independent of the nature of surfaces. Okay, and with the increase in the relative velocity of the friction surfaces, the force of friction also increases. So these are some of the laws of friction with respect to skin friction. Similarly we have discussed with respect to solid friction and all. Okay, now I believe all of you already know about this particular term which we have constantly been using, that is nothing but the coefficient of friction. And I believe there is no need to explain it further. So if this is a kind of block, okay, suppose which is there on a placed on a it is resting on a rough horizontal plane. Okay, and so in that particular case I believe all of you already know is the coefficient of friction, which is generally denoted by mu, is the ratio of the force of friction. Okay, that is there, okay, which is acting opposite to the applied force. Okay, so and the normal reaction. So this is the normal reaction. Okay, this is the weight of this particular body, and this is the applied force. Okay, P, and in the opposite direction to the, because of this applied force actually this way it will have the either the body will either get the velocity or it will tend to have the motion in this particular direction. So the force of friction will act opposite to it. And this is nothing but a kind of resultant between this normal reaction and the force of friction. Okay, which is making an angle phi with the normal reaction. When we discuss the different angles. Okay, so in that particular case, that equal to mu r or mu equal to f by r.
Audio is not clear.
Clear now? I think I don't know why today it's
Yes.
getting disturbed. So from this expression, okay, so we already know f equal to from that here what we can write f equal to mu r, that is the force of friction. It's a multiplication of the this particular constant that was the coefficient of friction which depends on the nature of the two contacting surfaces, okay, and the normal reaction. So this angle phi that we have seen, okay, so there is another word that is known as the angle of friction. So how they're related, so you have seen that basically this s is nothing but the resultant, okay, and it is making this particular angle phi, okay, angle of friction. So this phi is known as the angle of friction, and how we can get it, tan phi equal to f by r. Okay, if you just take the tan alpha, tan of this particular angle, tan phi, it's nothing but f. It is same. Okay, this and this same. It will be f by r. Okay, or ultimately we have seen that mu equal to tan phi. That means if you know this about this particular angle of friction, then from there also you can know about the coefficient of friction. Similarly, in the previous case, it was the case of block resting on a horizontal plane. Similarly, the block it may be resting on rough inclined plane also. So in that particular case, the self weight will be in this particular direction. We already know. Okay, normal direction will be like this. Okay, and if you take the component of the weight, so if this angle is if this plane is making an angle theta, then this also angle will also be theta. Okay, and as because of this particular nature, so if we take the resultant of the component of this particular weight, okay, so this way it will have w cos theta component, will have the w sin theta component here in this particular direction, and this particular component is tending to give the motion to this particular body this way. Okay, and that means opposite to the tendency of the movement or of the movement, so we'll have the force of friction in this particular direction. Okay, so I think other thing you could, if just from the equilibrium condition, all of you can very easily check this thing. Okay, in engineering mechanics also you have done those things. I don't see like we don't have to. I believe we don't have to go through in details of this. Okay. Similarly, we have what like cone of friction. So, what is this particular cone of friction? So, if already we have seen that if the force P is made to revolve around an vertical axis, that is the force. This one. Okay. So now, if it is made to revolve around the vertical axis, the resultant already we had this S as the resultant from the previous diagram. Okay, so it is also going to revolve in this particular about a particular axis. Okay, and if this particular resultant as it revolves around this particular axis, okay, this is the suppose normal reaction was like this. Okay, if it revolves around this, okay, so whenever the p is rotated, so this resultant also will rotate. Okay, and if you consider about the vertical axis, okay, so it's going to sustain an a cone, okay, of angle 2 phi. So we have seen that actually in the previous case this angle was phi, if you recall from the previous diagram. So this angle is phi, right? So this angle is phi, and if you rotate it, okay, ultimately rotate p about r, okay, about the vertical axis. So this is also going to rotate, okay, and you are going to get a this particular cone, okay, having this angle as well as this angle phi plus phi 2 phi. Okay, that is what is being shown here, and this cone is known as this particular cone of friction. Okay, understood? Hello, am I audible?
Yes, sir.
Yes.
Okay, thank you. Okay. So I think after that, you just all of you can go through any tire machine book or engineering mechanics book, and you can, I believe all of you recall the force analysis of a sliding body or like that. Okay. So whenever you consider the friction, then just from the if you resolve the forces horizontally and vertically, or sometimes which is in along the plane or perpendicular to the plane like that. Okay. And just force analysis if you do, okay, then that kind of force analysis all of you can very easily do. Yes. So that is basically about the initial thing about the friction, and why we are discussing all those things once again, because we are going to discuss something about bearing, friction classes, and brakes. Okay, that's why the initial things we have discussed. Okay, and why with respect to bearing we are talking about the friction, because see, whenever we know that in normal case these bearings and all, okay, they support the shaft, right? So those things you already know. But apart while you consider about supporting that particular rotating shaft in a particular bearing, so we know that that means the friction, as the surfaces are coming in contact and they have got the relative motion between them, that means the friction will come. Okay, so that's why this condition of friction we are just discussing. Okay, so right now we are not going to talk about the, you can say, the exactly the utilization of bearing and all or like that, but we are trying to correlate the friction, okay, how it is important and what are the things that we should know. Okay, so now when a shaft is rotating in a bearing, generally what we do, a pivot or a collar, is provided on the shaft so as to take up the axial thrust. Okay, so we know that these bearings, okay, apart from supporting this particular, suppose whatever is the shaft, okay, so they take up the loading, right? So or the thrust load, sometimes the axial load or the thrust load. Okay. So now in case of axial loading, whenever we are thinking of the application is like a thrust bearing or the axial thrust that is it has to take, then to take it properly, we generally use a pivot or a collar. Okay, whose intention is or whose use is to it actually takes up this axial thrust. Otherwise, what will happen? The bearing and the shaft it may misalign, and if the alignment is lost, okay, then the bearing will not be able to properly support the shaft, and if the shaft misplaces from its position, whatever is the axis of rotation it is intended to have, so ultimately it's a kind of failure. Okay, so that's why to take up the proper axial or thrust loading, okay, we generally provide the pivot or the color is generally provided. Okay, so for this class, that's the introductory kind of thing only we'll have. Okay, and in the next class onwards, we'll just discuss about suppose two theories like the condition of uniform wear, uniform pressure, and all. Okay, how it can be correlated with respect to this particular your this bearings. Okay, so and apart from that, I even though it is not there in your uh, course, okay, but I believe all of you have heard about weights. So you can do one thing, just you can check how the wedge friction is there, how we can use wedges and all, okay, for supporting also. So I believe all of you have seen this kind of some wedge block in maybe in the sometimes to support the blocks and all, okay, support something, or sometimes in the making of bridges also you might have seen this kind of block, this shape block, okay, those are known as the wedge. Okay, and there is another thing like wedge friction. Okay, it's a easy thing only, all of you already know about other thing, but it's a kind of inclined surface. So you can just see how wedge can support other thing. Okay, so with this, we'll stop here today. If you have any question, you can ask. In the next class, we'll discuss the other thing.
Clear, sir.
Okay, all of you have understood, right? So now then, I'll be taking the
Yes,
attendance.
sir.
Okay, I'll be taking the attendance for today. So you please, I'll be calling your names. You respond to your names. Okay, one by one. Samim, Samim, Hiteshwar,
Yes, sir.
Biswajit,
Yes, sir.
Catherine,
Yes, sir.
Tapas,
Present, sir.
Jigyas,
Present, sir.
Shubham, Shubham. I can see Shubham, but I think you are not active. Andreas,
Yes, sir.
Ashish,
Present, sir.
Khandip, Khandip, not here. Bisal,
Present, sir.
Semphang,
Present, sir.
Alvyaksina,
Yes, sir.
Jorian, Jorian, Jorian is not here. Sensing Dao,
Yes, sir.
Mario,
Yes, sir.
Norangchi, Norangchi. I can see Norangchi, but are you here? Joydeep,
Yes, sir.
Joydeep.
Yes, sir.
Okay, so it's a last call for Shubham. I can see Shubham, but
Sir,
I believe.
present, sir. Present, sir.
Uh, okay, Khandip is here. No, Khandip is not here. Jorian is here. No, and Samim also is not here. Okay, so
Sir, Shubham present.
yeah, Shubham given. Okay, so thank you everyone for joining. So we'll meet in the next class.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir. Bye, sir.
Okay, bye.